Okay, so here we are back in Java again, working with becker.robots, and we also have java.util for some more extra tools in that library. So today we're going to be working on a problem where we're going to need to copy in this code, which will be in the description. And what this is going to do is, this will, if we compile it, these will create walls in our city, right here, and we have a hole. And our job is to write the code that gets this robot to go along the wall until it finds the hole and then go through. So first we got to work through the logic of it. So one thing to notice is that we have streets running horizontally and avenues running up and down. And this street 2 right here, and we have street 1 and street 0, he's on street 1. And we want him to follow the wall until he goes through the hole. So we don't want him to drift away from street 1. We don't want him to go up, down. We just want him to move horizontally until he finds the hole. So one thing we can do is we can say, while you're on street 1, continue to do it. Or continue to search for the hole. And then once you're, say, on street 2, that means you've gone through the hole, so you can stop. So the way we're going to do this is we're going to do a while loop. So while Joe, that's the robot's name with capital J, Joe.get street, that gets his street, while it's less than 2. And then we have the brackets to contain our code for that. So what I mean by less than 2 is that basically he's on 1, which is a number less than 2. If he goes through the hole, he'll be on intersection 2, 4, which is street 2, which is equal to 2, which is not less than 2, because this is not a less than or equal to, this is just a less than. So he'll stop once he goes through. So now we need to think through all the different possibilities of robot Joe's position and how he can find the hole. So the first position we're going to think of, and we're going to assume that he always starts on a wall. And we're going to assume we don't know where this hole is. He could be above the hole. He could be right here. Or the hole could be hundreds of units out here. It could be behind him. But we'll assume it's not behind him. And we'll also assume that he is already, he's either above it or to the left of the hole. That way we can write the code rather easily. So, the way to find this hole, so we've defined when he goes through the hole. So while he hasn't gone through the hole is basically what the statement says. Do the code, but once he's gone through, the statement will become false and he will stop doing it. So first thing we're going to do, he could start looking into nothingness. There's nothing in front of him. So we're going to write if Joe.front is clear. I'm writing an if inside a while loop. While the front is clear, Joe.turn left. And we're going to do this 3 times because we don't have a turn right command. But basically we're going to have him turn right because we're assuming that the wall's below him. So Joe.turn right. So let's compile and see what this does. The front's clear, so he's going to turn right, which is 3 left turns, which he did rather fast there. But now the front's not clear, and we don't have a statement in here to deal with that. So let's add one, still inside the while loop. Remember this bracket ends the while loop, but not inside this if statement. If exclamation mark Joe.front is clear, and exclamation mark flips the statement. So now while the front is not clear, he's facing the wall, so let's have him turn left, so he's facing forward and move, so we can check the next one. Joe.turn left, and then Joe.move. Because if we don't have this move, he'll turn left, but then the front will be clear, and he'll turn right, and so he'll just keep on looking back and forth between here at the wall and not at the wall. So now he's going to move. So if we go ahead and compile this, he's going to check, and it doesn't stop for us, which is kind of annoying. I'll slow it down a little bit. But he saw that it was not clear, and it wasn't clear, so he turned left, and now he's going to move. He moves. He turns right. It's not clear. And then he turns left and moves. He keeps on doing that, but now he gets stuck because he keeps on turning, and it's always clear. So he just keeps on turning right and turning right, which is a series of left turns. So it just gets stuck in an infinite loop. The problem is we don't have a statement to deal with. After he turns right, the front might not be clear. This deals with that scenario. But when he finds the hole, the front is going to be clear once he turns right. So how do we deal with that? Well, we're going to have to write another statement. After that, if Joe.front is clear again, clear, then we're going to have another statement. So if the front's clear twice in a row, that means he's facing the hole, then Joe.move is what we're going to want to do. And we're going to go ahead and compile this. Alright, now we're going to run it. So, whoops, it just crashed. Well, we can still run the program, so that's alright. So he's going to keep on going and turning, and then he's going to see the front's clear, and he's going to move. Oh, it didn't crash. I don't know why I did that. Must have closed an accident. So then he sees. So let's go through the logic of what just happened, and actually I'll run it again, but slower. Whoops. Alright, let's run it slowly. So he turns right. The front's not clear, so he turns left and moves. Turns right. Front's not clear, so he turns left and moves. Turns right. Front's not clear, so he turns left and moves. Turns right. The front is clear again, so it goes onto this one, and he moves. And then it goes onto this, except it checks this first. And it says, while the street is less than 2, do all this. But now he's on street 2. 2 is equal to 2, not less than 2, so it stops. So he has now completed his journey, and he's found the hole. One thing to do is to move the hole. So we're going to go ahead and replace, we have the hole in the middle, but we want to make sure this works no matter where the hole is. So the hole is here on Avenue 4. We have a missing piece. So there's no, this is the street. They're all 1 because it's a straight line. And then 1, 2, 3, missing 4, 5, 6, 7. On 4 there's a missing piece. So let's go ahead and change that by changing this one to 4. So now the missing part is on 3. So it'll be closer to him. To end and compile. And let's see if he can still find the hole. Yep, so he still finds the hole and goes through. So our logic works regardless of how far away the hole is. He'll just keep on going at it until he goes far enough out that he finds a hole. And what happens if there's no hole? What if we have 3, 4, 5, 6? What if we change it such that there's no hole? What will happen? Well, by the logic, he should go out to here. It doesn't matter if there's walls to the right of the hole or not, or it shouldn't. So he's going to keep on going right of the wall, and then once he realizes, or once he goes over the wall and there's no hole, he's going to move. He still hits street 2. So basically, if there's a hole, he'll go through it. If there's no hole, he'll go all the way to the end, down. So basically, if you have a line of walls, and you want to find the very first hole in it and go down, this code will do that for you. Thanks for tuning into my Java tutorial. I hope to catch you later.